It's my great pleasure and privilege to introduce you to our keynote speaker, Professor Rolf Inge Godøy, who is Professor of Music Theory at the Department of Musicology at the University of Oslo. His main research interest is in the phenomenological approaches to music theory, which means taking our subjective experiences as the point of departure for music theory. And this work has been expanded to include research on music-related body motion in performance and listening, using various conceptual and technological tools to explore the relationships between sound and body motion in the experience of music. And just on a personal note, he was one of the main influences for my own PhD, so I read many of your papers, and they're very stimulating for my own research. Rolf Inge Godøy has published over 160 papers, book chapters. I'm not going to name all of them now, just maybe one that he published together with Mark Lehmann, Musical Gestures, Sound, Movement and Meaning from 2010. I think that was a really important contribution. And one of his latest book chapters, Key Postures, Trajectories and Sonic Shapes, which is a recent OUP volume on music and shape, also a project that I contributed to. So I was really privileged to have him here today and to talk to us about impulse-driven sound motion objects in musical imagery. We're very much looking forward to your presentation, Rolf Inge.
Well, thank you very much, Mats, for your kind words, and thanks to all of you organizers for organizing. It's a marvelous event. It's a luxury to, in our day and age of hardcore science, to have mind wandering. I really need to say that because it's much needed. I feel it's long overdue that we have a bit more, how to say, creative attitudes towards what we are actually dealing with. So I'm very happy to be here. So my topic is maybe a bit daunting, but it does have to do with musical imagery, I can assure you, since you mentioned it. And I should also say that the background for this, as I say here, is actually in Berlin, 1977. We had a workshop over at the Philharmonie, this Preußische Kulturbesitz library, and I was asked in our Arbeitskreis, which consists of people from Hamburg, Ghent, Genoa, and so on, to organize a workshop. And I said, musical imagery. And it was agreed. And exactly at that same year, this book by Alain Berthoz called Le Sens du Mouvement came out, and sort of everything converged. And well, we started asking questions ahead of a conference that was arranged by me in Oslo in 1999. And the main question was, at that time, what triggers musical imagery in our minds? So the tentative answer that I had ready in 97, for my part, not common agreement about this, but mental images of body motion can trigger images of sound in our minds. And now, 21 years later, in 2018, the answer is basically the same, but with the added focus on what I shall focus on now, intermittent cognition, meaning impulses, that it's not a continuous process, but more a discontinuous process of triggering musical imagery. It's a bit speculative, but I'll try as best I can to substantiate that with other relevant research. So the main idea of my talk today is intermittency, meaning discontinuity, in perception and motion, which is not well understood, and may have explanatory potential for musical features. So just to get started, some sound-producing wrist motion to set you off. Okay, that was a little piece of musical imagery. Did you hear it? Was it okay? Yeah, thank you. So it's a daunting outline, but I have 1 hour, so just cut me off when I've spent this hour. First of all, musical imagery. Ahead of this conference of musical imagery, CMI as we called it, in 1999, I made a call for paper, and I made the following definition. Musical imagery is our mental capacity for imagining musical sound in the absence of a directly audible sound source, meaning that we can recall and re-experience or even invent new musical sound through our inner ear. So there are obvious links with memory, as well as primary perception. And upon reflection in the years after this, I came to realize that it wasn't as straightforward as the above definition could maybe signify, namely that at every single step of primary perception, musical imagery is involved by the simple fact that music passes and it's gone, and you somehow need to keep it in memory. So since that time, in 1999, we have had very many brain observation studies of musical imagery. I recall we got a few papers at that time on fMRI, but the big deluge, stream of fMRI came after the millennium, I think, at least in this domain, and also for other methods of brain observation. We have also had a number of studies on the content, for instance, what was mentioned on involuntary musical imagery. But as far as I can see, we have had not that many studies on what triggers musical imagery, voluntary musical imagery. So why is this important? Well, I think that there are many practical uses of musical imagery, not just mind-wandering without any clearly defined task, which can be useful enough, but very precisely in the use of musical imagery, the use in mental practice for performance. It's possible to practice large works of music just by lying down on a sofa. Composition, also to compose a piece of music on a long plane journey. And also discovering new musical features. And I like to use the term hermeneutical circle of shifting between sound and motion in our minds. So motion imagery is a general method of exploration, valid also in other domains, for instance, touching by sight, which was actually a quote by Cézanne, taken up again by the already mentioned Alain Berthoz, when he shows us this picture of an iron-wrought gate. And what he says is, palper par le regard, as a touching by seeing. So it is, in a very simple sense, visual perception that also uses motor imagery. What I've been able to surmise from these past 21 years of musical imagery, and I was also very pleased to say before that Koslin and Godøy, the debate, I should have put it in because I'm quite familiar with that from the 1980s when I did my PhD, and the confrontations were quite severe, believe me, between the propositionalists on one side and the pictorialists on the other side. And as was hinted, it seems that the pictorialists have won. That the black box model of some computational device is not really, it's not on the scrap heap, but its significance is not so obvious anymore. Anyway, functional equivalence means that there is a parallelism between real-world perception, so to speak, and imagery. You may correct me, there are nuances here, I realize, but the point is that motion-related imagery seems quite prominent in this multimodal triggering, where we have vision, touch, and haptics, and even more. So what we have done is to rely, sorry, I skipped, the methods, are to a large extent self-report, of course. You ask people what they think. We haven't really done that. We have rather relied on behavioral data. We ask people to move and show with the body motion what images or musical sound they have in their minds. So that's an approach which may be debatable because there are also limitations what people can do. If you ask people who are not used to dance bang like that to a piece of ligeti, they tend to be initially maybe a bit paralyzed, but after a while they loosen up and do something. So what are the triggers? Again, this is a concoction of mine. Motor mimetic cognition, meaning covert, but sometimes also overt simulation of music-related motion. And we have two main classes here, sound producing motion and sound accompanying motion. So we now see some elements of music-related body motion. And in doing that, I go on to the next section about motor theory. Music may be experienced as a series of multimodal chunks, what we call sound motion objects, evoked by sensation of sound producing body motion, in what we call a motor mimetic cognition. So the point is, in this schematic overview here, if you are listening to continuous sound here, you are probably having some kind of motion sensation, and you also know enough about sound producing motion, so you take into account certain constraints of the body, and you end up with chunks of sound motion objects. That's our primary model of how musical imagery works, and also, of course, musical perception. So let's have an example and see how the sound is included in the sound producing body motion shapes of this drum set excerpt. Okay, it went quite fast, so I made a slow motion version for us who are not drummers. Okay, I think that we may seem to perceive a stream of sound and body motion centered on highly accented points in time, with these points surrounded by what may be called prefixes and suffixes. So we have one point, and we have a trajectory up to that and a trajectory away from that. I'll show you more details. The accented points are produced by so-called ballistic motion, which you know from golf, tennis, baseball. It's the kind of motion where you hit and you really don't control it once you have started the motion, and that's why it's called open loop or discontinuous control impulses. So ending up with what we can call impulse-driven sound motion objects, we suggest that these sound motion objects are the result of intermittent motor control and intermittent effort, that there is an unequal distribution of attention and effort in the course of the musical performance, and that this also shapes our perception of it by projection of motor images onto what we are perceiving. So this is essentially the main point of the so-called motor theory of perception, which started in linguistics in the 1960s and received quite a lot of criticism because people said that you cannot really pick out any kind of muscular response from the vocal cords when people listen to language. Now, in our day and age, this has been vindicated by fMRI, where you can show very clearly that you have activation of certain motor areas in auditory perception. So I think it's much safer now to say that the proponents of motor theory really had a point, and that perception and cognition is a process of constant mental simulation. So usually it's in the form of a covert imitation of the motion of others and the assumed motion behind what we hear, even though we don't see what people are doing. And as I said, the neurocognitive research seems to confirm this. And we can also figure out quite a lot of this by studying music-related motion in performance, such as in the following. Okay, what we saw in this classic performance, Glenn Gould, Webern variations, it's a different type of, different kinds of body motion. Some are, of course, necessary to produce the sound, but others are more choreographic interpretations of the whole context, which means that actually, when you study music-related motion, you have motion that may be very multifunctional, but at the end of the day, the main point is that the motion is there. And there is no denying that the motion means something very specific for be that the musicians or the audience. So to summarize some development which has been going on in the past couple of decades, there has been, since Berthaud's book, a huge amount of literature of so-called embodied cognition. And we have also, fortunately, had a whole lot of concrete research like this quantity of motion, acceleration, jerk, etc., which can tell us much more about the affective features of music. And lastly now, just want to show you what we are doing now. We are trying to get a better image of the effort that's actually being put into music by so-called electromyographic measurements, meaning that instead of just guessing how much force is being put into some music performance, we can get a little bit more concrete from the muscle activation. So you are going to see an accelerando on a snare drum, two hands, and at some point you'll see that the muscles used tend to change. So here you go. Up. No? Oops, sorry, okay. Okay, sorry, this didn't work out as intended. The point was to show to you that from the regular slow beats here with the accelerando, all of a sudden this muscle here, which is the triceps, kicks in. Why does it do that? Why doesn't the performer use the triceps earlier? Well, I'm not a drummer, but the performer here is a professional drummer, actually. And the answer is that if you go above a certain threshold, you need to have more power. So it kicks in the triceps, which is there. And again, this is just one of a zillion possible illustrations of how effort can be an integral part of what musicians do and also what we actually perceive. So in general, this perception action cycle, which has been brought to the fore in the cognitive sciences now for several decades, is of course a truism, but there is some difficulty with that when it comes to temporality. Because our system, our body, our muscular control system isn't the fastest, and this idea of continuous updating, like a thermostat on a radiator, which isn't continuous either, but it tends to kick in and turn off and turn on. This requires too much time to work well in demanding tasks of musical performance. So that means we shall have to look at time scales, and the background for this is more than 100 years debate on the relationship between continuity and discontinuity in perception and cognition from the time of Edmund Husserl and William Stahl, a very interesting character, by the way, who wrote a paper in 1905. It's in Gothic. It's called Die psychische Präsenzzeit, and highly recommended, because these people were in some kind of dialogue, including William James, really exciting times, and where they discussed probably things that are related to mind wandering in the sense of continuity and discontinuity. Anyway, Husserl's first version of Phänomenologie des inneren Zeitbewusstseins in 1893, he said something to the order that chunking is necessary, even though sensations are unfolding continuously or sequentially in time. Chunks also need to be perceived and conceived instantaneously in now points, Jetzt-Punkte. So this idea of chunking is very fundamental to phenomenological thinking, and was adapted also by Pierre Schaeffer and GRM, the Groupe de Recherche Musicale, and has been continued in some projects afterwards, which I would like to mention. This one, not very well known, Unité Sémiotique Temporelle by our colleagues in Marseille, and the Sounding Object project, mostly by our Italian colleagues. And what they did was to say that we can have very short, or in the 0.5 roughly, seconds duration range, sounds that make sense.
Mais... Yeah?
Okay, you may probably be familiar with this diagram from Husserl. It's a bit simplified, the version of it that I made. It's saying that if you have temporality along the axis here, you have the sensation of now, which is composite of what you just experienced, and also predictive as to the future. So the idea of an instant is quite interesting in our context, because it is also anticipatory, which I think is one of the big advances now in motor control, that we are starting to understand the necessity of anticipatory cognition. So returning to the general question of timescales in musical experience, say that music is continuous, unfolding. How can it become objects? Well, the possible answer is in timescale analysis, meaning that we try to differentiate the various components that go into the production and the perception of musical sound. So in psychoacoustics, there has been quite a lot of work, for instance, BCJ Moore, 1995, and more recent publications, how long time you need to hear in order to perceive pitch, to perceive a timbre, and so on. It's complicated. It's more complicated than one used to believe, because it's so dependent upon context and content. A very interesting study by Gjerding and Perrot from 2008 called Turning the Dial, meaning you turn around on the knob of a tuner, and they can document that at 325 milliseconds you are able to identify quite a lot, and even on 250. So let's hear 325 milliseconds sounds like this. And 250. Okay, this wonderful book by Bob Snyder, Music and Memory, makes it into this area here of melodic and rhythmic chunking. You may want to have a look at that. For our own part, we have made this rough 3-level distinction, what we call the sub-chunk level, which is below roughly 0.5 seconds, chunk level, which is above 0.5 up to 5 seconds, as with Pierre Schaeffer's sonic objects, and the supra-chunk level, which is that which contains concatenations of chunks into larger scale units to sections, movements, and so on. So that could be well and good, and I think there are arguments in favor of this triple division. But in music, what is the most significant level? Well, raising criticism, which sometimes I've experienced, doesn't go down very well with musicology colleagues, saying that grand scale forms are not quite as robust as maybe, let's say, Schenkerian analysis, to be very nasty now, will make us believe that you have the Urlinje. What happens if you change this a little bit? Does that really ruin an aesthetic experience? Well, it remains to be really studied much more. So this paper by Etano and Grano from 2006 is one of the few which does this in a more experimental way of chopping up a piece of music and gluing it together and see what happens. So for Schaeffer, the theory of sonic objects, which I have really come from, says very clearly that at this time scale of the 0.5 to 5 seconds, you have so much aesthetic musical information that it does have certain privileged situation. It evolved out of a necessity in the early days of the musique concrète, where they had to make looped fragments on 78 records. And then they discovered that if you repeatedly listen to these loops, you have two options. Either you go mad, or you start to really get into the substance of the shape of the sound. So the sonic object is then perceived as a gestalt, as a holistically perceived unit that also contains the most salient features of the music. I already mentioned some of the artistic research at GRM and also the more semiotic research of these people, but also from more, how to say it, neuroscience perspective, there has been some interesting work on auditory objects. And also in our own work on sound-related motion, we also see motion shapes that tend to have roughly the same duration scope. Lastly, there has been this long debate from Lashley in the 1950s up to Klappe-Jagashinsky that I think is fairly good arguments in favor of this object-based perception in music. What this boils down to, though, in terms of motor control, is that the motor control is intermittent, that it cannot be continuous, or there are big difficulties in claiming that it is continuous. Now, before I get into the details of that, I just want to show you a bit more what stems from Schaeffer's categories of sound, of so-called impulsive, sustained, and iterative, which very interestingly are biomechanical constraints. Because if you consider impulsive motion like hitting a golf club or baseball bat, it's something that you do in one go, so-called ballistic motion. If you are going to make sustained motion, you need to have a continuous energy transfer. If you are making an iterative motion, you need to have a different set of muscles, for instance, this shaking back and forth, or in the case of a tremolo on a string instrument, you go like this. And it's very clearly, we have done studies in bowing that you start with a slow, full bow, and you can see very clearly at some point, I can show you the graphs here, you switch over, like in the drumming, you switch over to a different set of muscles at a certain point in time, just simply to make it. So we have this convergence of parallelisms of production motion and actual sound features. So let's hear some examples of this. First, the impulsive. Okay, it's a hitting percussive sound. The sustained is a scraped sound here. And the iterative is a back and forth sound. Then we can have so-called phase transition between these categories based on duration and density of events. The notion of phase transition is something that comes from dynamical science theory and is now being recognized in human movement science also, that you switch from one way of doing it to another way, depending upon how fast. So the classic example is the parallel phase, and you do an acceleranduet at some point, unless you are extraordinarily clever with this, it flips over to be in antiphase. And it's a limitation probably on our central system. Horse that goes from trot to gallop is also a phase transition. And this is quite important for how cohesion is created in musical sound and in musical motion. Okay, so let's now have a little bit more of types of object from Pierre Schaeffer. You'll hear a long sequence of rather long sounds first.
Guy! Attends-moi! Tiens, mais... Oh! Il est déjà parti?
Okay, I think nowadays, this was from the 1950s and 60s, nowadays the field of so-called ecological acoustics would really grab this and say this is ours, because it's very much tied to significance of events. A very interesting domain, which is well worth also looking into from a musical point of view. What Schaeffer did in the 1950s and 60s was to chop these sounds up according to shape and associate them directly with the body motion. So you'll hear another excerpt where the master himself, Schaeffer, reads in French. And for those who don't follow the French, I'll just point here.
Ainsi, combinant entretien soutenu et intonation fixe, nous pourrons rapprocher
Guy!
puis, toujours avec entretien soutenu, des intonations variables.
Oh!
Puis, sans entretien, des impulsions fixes en intonation.
Mais
Et enfin, des impulsions variables en intonation.
tiens,
Okay, so this goes into a music theory based on shape and motion, which is very general, which can be applied to music from other cultures, to music with different types of sounds. Furthermore, it goes into what's called morphology, which tries to zoom into features of the sound. So there are some very sophisticated concepts there. I just want to very quickly show you this, which is called a grain, which sounds like this. And also a slower kind of fluctuation, which could be translated as gait. Okay, so the point is that we have here, I'll skip a little, but here you can see it's a bit daunting, but the point is to make categories of auditory features from a top-down manner. And this was again done initially only on sound, and which fits very well with the motion trajectories, which we have tried to say in some of our publications. Here we have an example of our colleagues in Maasai. I think I'll just skip that for lack of time. So, yes. Granted that we believe chunks exist. Okay, you may disagree, but still, let's say, for the sake of argument, we go on now. Then, how does it work? So there is an enigma here: how what unfolds in time sequentially can be instantaneous. So the answer is, of course, memory. We have echoic memory. Exactly how that works is still very enigmatic. It does work. That's obvious, both for us and our colleagues in the animal kingdom. So the same goes for movement and imagery, I should add, of motion, a kind of short-term memory. And also works for anticipation in motor cognition. So there is now ample evidence of anticipatory cognition in motor control, for instance, with as I mentioned, Lashley Rosenbaum, and also for goal-directed hierarchies. But again, from observational data, this is much more tricky. You can see why. This is a very simple 240 frames per second video of a person playing piano. And how on earth should you be able to chop that up into chunks? Well, it goes on. The problem is that we are never still. So we could do some kind of what's called thresholding. We could try to detect periodicity, we could try to detect beats, we could try to use all kinds of sophisticated cues for analyzing the signal, which was done by Hogan and Sterner, one of the couple of leading motion scientists today. And they have this very interesting paper, 2007, which I recommend to you. I'll just have to skip it a little bit fast, because what they do is that they look at an idealized case where you actually have zero motion between certain points. What they do further on is perhaps much more realistic, namely to have a measure of the so-called jerk, arriving at something called a mean square jerk. And this is something for you Brits, something very funny. But for us others, it's straightforward math, meaning that you try to give a value for how jerky some movement is. So Michael Jackson would typically have a very high MSJ level, whereas Swan Lake would probably be quite low. So there are some definitions floating around, but I'll hurry on. I just want to tell to you that all these things exist and are concerned with subjectively experienced affective features in music-associated motion. So now going on to a little bit of shapes. It was a very cold winter. That's what my window looked like. So we have shapes, and as Mats mentioned, we have the book just came out called Music and Shapes, and I shouldn't be so marketing concerned, but it's a very interesting concept, and I hope it can be useful also for the imagery debate, because shapes is a way into musical imagery, in my opinion. So very quickly, we have, of course, well-known shapes in music. In this case, we have formantic shapes of first a trumpet sound. Then I took the trumpet sound and passed it through a formantic filter of the French AOE. It sounds like this. So what you can see is, of course, in the time domain, it just changes, and in the frequency domain, it also changes. It doesn't make that much sense, but it could make more sense if you could somehow get a shape model of the mouth. It would be maybe closer. Lastly, this very famous Rainer Weringer's image of liquidis articulation. I think all these graphics are important for music imagery. And it was mentioned the imagery debate, and I should say that in the the struggle between propositionalists and imagists, these guys, René Thom and Jean Petitot, they really were on the imagist sides, and in particular the idea of understanding by pictures is very prominent. And this famous quote by René Thom, that the first objective is to characterize a phenomenon as shape, as a spatial shape. To understand means, first of all, to geometricize. So, to summarize this, I think we have, at this stage, very good reasons to cultivate graphical shapes if we are going to go more into musical imagery. At least it could be one access point, since we are talking about visual auditory imagery. Okay, I'm sorry now, I see again, I miscalculated the time, but I just want to summarize the shape cognition here is something that I'm going to work on the coming years at my work at the University of Oslo. I forgot to mention the Center of Excellence, which we are very happy to have gotten, which started out now 1st of January and will be running for 10 years. And we are all very excited. The main topic is rhythm, time, and motion. So it goes right into what we are talking about here. Now, the point was to use shape as a kind of unifying element here. Okay. Similarity is part of the whole issue. We had a very interesting workshop on similarity at the Lawrence Institute in Leiden a couple of years back. And again, I realized how huge these topics are. So I tried to focus a little bit here on the motor aspects of similarity, how it can be used in musical imagery. So again, the motor mimetic cognition, as I defined it, is a mental imitation of sound producing or sound accompanying body motion. So methodologically, if we assume that people somehow are able to imagine some motion that triggers sound, could we ask people to make motion when they listen to music? Well, that's what we have done, and we have done it for several years. The main point to remember is that we have what are called approximate imitation. So this is another point which has been a bit tricky, I think, in cognitive science, that maybe we haven't been well enough aware of that we also have very valuable information which is sketchy, which is incomplete. So that's why I like to provoke people by playing this quasi-language.
Huronnante doudou malibranche turluteux, en rinlant prontiac et rufleur.
Okay, now we do the Italian.
Angiovino, Antore nomati, nelle ciabatto barcanti, cirpo rivetto.
Now the next one will be German.
Yeah.
Und meine Tücher geruhten rich, seine Kufen 30 heute Böhre abendfraulich.
Okay, to us outsiders it sounds all okay, but it's not.
My main elements would be bass kick scratch, where it's or you could do different types of ways of what I mean, and flip it like that, and then like when you were saying with the words, with the and then you put it together. One, two.
Okay, again, think of this in terms of musical imagery. How the motor imagery can perhaps be part of it. So, okay, it's about very sophisticated motor control, but there is a lot that goes into this, which I think can be studied, except for that we always have the limitation that people are timid, people really have more sensations than they are able to express. Just want to show you very quickly some other things we have done. We have done a lot of studies on air instrument performance, air guitar, air piano, and so on, and found some quite interesting stuff. People who said that they were tone deaf and they were still able to hear up and down on a piano and so on. Just very quickly, something we did 12 years ago called sound tracing, which we still do. 9 different subjects. Okay, so and a bit more hardcore science here, where we have calculated spectral centroid, and we did this with a 3-dimensional motion capture. Okay, so we get out more controlled data. I'll skip. Okay, so in similarity, can we have this kind of simple definition of similarity? No, I'm afraid not. We need to be a bit more careful. So in the motor perspective, what we have done is to try to follow a bit more analysis by synthesis, and this is an interesting way of thinking analysis by synthesis for those who may not be familiar, that you can take, let's say, 2 features and gradually have incremental change along one feature axis and then another feature axis. So let's say a typical cup might be this one here in the middle, which is halfway along that axis and halfway along that axis. So that is also a strategy for teasing out what are the different factors in musical imagery. Okay, now I'll go on to something which I was really going to focus on, namely constraints. So in terms of musical imagery, provided we are relating somehow to real-world instrumental, acoustic, ergonomical, etc. factors, it seems to me obvious that in a certain sense they will be transformed also and transported into our imagery. So going back to the imagery debate in the 80s was a question about chimeras, the Sphinx. The Sphinx is a human and an animal put together. And as components, they are both possible, but as put together, it's impossible, at least from our current knowledge of biology. You see the point? So the same goes, I would think, for musical imagery also. So we have these things about biomechanics, motor control, idioms for voice, a number of constraints, and how do they actually kick in what we could call musical translations. So Google Translate is a good example where things really don't work because the idioms are not taken care of. Let's just have a very quick example here when it comes to embodied cognition. If you look at the top figure here, it's from Beethoven Piano Sonata, A-flat major. This was a text I wrote in the old days when I was teaching orchestration. It's in Norwegian. But anyway, the point is that this figure here on a string instrument, any string players here? Yes? You play that very fast. Is that a comfortable thing to do? You think so?
I would say it's fine.
If you transpose it down a semitone to D and have the open D string, it's much easier. Yeah. Anyway, I was hoping you would say it was terribly difficult, but never mind. The point is that if you are going to translate that piano figure, which is back and forth rolling like this, to somehow a string player, you have this insane thing there which would be absolutely disastrous because it wouldn't work in terms of coordination. The translation trick is to say that the back and forth rolling you need to translate into an up and down tremolo. Okay? So it's an idiomatic translation. So here you have this version, or even more this version, which is more true to the intention of Beethoven than this one or that one just done as it is. And another example from a Chopin prelude where you need to somehow compensate for the workings of the pedal to put on some sustained instruments in the background. Now, you may think that this is rather far off from musical imagery, but my point is this, that we are all the time working up against constraints, which has to do with body motion. One of the most significant constraints is what is called the psychological refractory period, which is the basis for so-called fakes in sports. Okay, I'm glad I'm not a soccer player. The point is that this feedback control loop takes time. And that means that we have actually, together with that, several constraints, and now I'll come back to the phase transition, so that you have a series of impulsive motions which are widely spaced, and you squeeze them all together, then you end up here with a phase transition motion, which is more an undulation instead of one by one. So this we have demonstrated with the foot pedal on a drum set, that you have a disappearance of this recoil dip. I cannot see it perfectly here, but you can have a look at it later on if you like. This is similar with a marimba performance, a tremolo of two mallets in one hand, where you should see the recoil disappearing when it gets too fast. So this means that we do have a number of constraints, and then I arrive at the intermittency, which says that we need to have pre-programming at the chunk level of body motion. It's one of our constraints. If you recall the soccer player and the so-called psychological refractory period, what the psychological refractory period says is that basically you cannot intervene at a certain level of time because the organism is too slow. So you need to be prepared and pre-program whatever it is that you want to do. So out of this grows the following observation. this is a pianist performing a little bit altered version of a waltz by Grieg. Okay, you see here, yes, the position, velocity, and acceleration. You see how the velocity is reversed at the bottom here, where the pianist hits the bottom note. So it's what we could call a collision point, where the velocity switches from signature from positive to negative. So we think that these velocity switching points are quite crucial for how we perceive motion. And sorry, I should say also that what's between these collision points, if you see here, it's 1, 2, 3, 1, 2, 3. It's the 2 and 3 are included in the same motion trajectory as starting out from the 1 until the next one. So this is what we talk about in co-articulation. Co-articulation means the fusion of otherwise separate motions into one larger motion chunk. And there is a very good reason. According to David Rosenbaum, it's a blessing for us as behaving organisms. Think about a typist who could move only one finger at a time. Lacking the capacity for finger co-articulation, the person's typing speed would be very slow. Simultaneous movements of the fingers allow for rapid responding, just as concurrent movements of the tongue, lips, and velum allow for rapid speech. Co-articulation is an effective method for increasing response speed, given that individual effectors, body parts used for movement, may move relatively slowly. So there is a lot of studies in linguistics and also some in human movement science, but not so much in music. And to skip to what yes, it's based on also another part of this is about key postures, meaning postures at significant moments in time, which is well known from animation, where you have certain postures that define what you do, and what happens between these postures is co-articulation. So this was the point that I wanted to make, namely that you have a single gesture on top here. Let's say that you start from an initial position and you hit a drum and you bounce back. You have a prefix until that key posture and you have a suffix back. Again, if you squeeze this more together, you tend to have a more continuous undulating trajectory between the different key postures. So this went a little bit too fast, but I'll try to summarize. The point is that this movement science perspective says that behavior is organized at certain stations, which are called key postures. Okay? And between these key postures, there may be usually continuous motion. So this is how the body, our organism, solves the puzzle of dealing with continuous motion, and also solves the constraint that our body isn't fast enough, as you could see with the soccer player and the psychological refractory period. So this is not my original idea. It's been done before in linguistics, but this is the model that we are currently working on in my sub-project, meaning that intermittent key postures coupled with co-articulation, it sounds a bit technical, but the point is that with this anticipatory cognition where you plan ahead, you imagine at some level of the cognitive apparatus where you are going, what you are going to hit, and the body takes care of making you go there. So I'm approaching the end. So a tentative model here is what we can speak about, a privileged time scale, which could be called a musical instant, which is roughly in the 0.5 seconds duration range, and it's related to control impulses. Again, our organism is too slow, so we cannot realistically have infinitely fine-grained feedback control. It needs to be intermittent. And these intermittent instants are focused on certain goal states, key postures. And this concerns also then the sense of effort, which we are trying now to document with so-called electromyographic measurements, EMGs. So we have then, to summarize this part, co-articulation in both the production and in the resultant sound. We have this intermittency of effort and intermittency of control. And we have velocity peaks at these impact points, key postures, which can be fairly accurately detected by good signal analysis. So very stylized. If you think of having an impulse at one point, you need to get there and back. If you have several in succession, you need to get there and back, which is similar to what I had shown before, but this is the generic model. And this has, in signal processing world, a parallel in what's called the impulse response. So without going into details, just mention for those who may be interested in discussing this with us, so-called Dirac impulse, which is an infinitely high peak, which you use typically for testing the response of a system, concert hall, acoustics, or also more complicated systems like we are talking about here. So what you can say is that you have a series of impulses that are so-called convolved with a response, and then you get more continuous motion trajectories out of it. There are some interesting publications here, in particular on human handwriting. This guy in Montreal, Raymond Plamondon, and others have done something quite similar. I wasn't aware of this until quite recently, namely that handwriting is also this impulse-driven, that you send an impulse and you have these continuous trajectories and a new impulse and a new trajectory. We have something in the EMG motion data called pre-motion silent period, which you can see here, PSP, which means that before you have a hitting motion, the muscle activity tends to go to zero or very low down. Because if you have attention before you hit, the hitting is very inefficient. So this is something that karate and golf players intuitively know. You need to relax and smack, off you go. So this is something that we are really looking for. I mean, it's a needle in a haystack of messy EMG data, but we are hoping. Yes. Okay, that was next to last. So, impulse-driven sound motion objects, that was the title. Continuous effort and attention, unlikely, yes. Intermittent control, optimal. Biomechanical need for exploiting rebound energy. So, that means we have convergence of constraints, which I believe is valid for musical sound production and secondarily also for musical imagery. So let's hear just a few examples at the end. Nope, that wasn't it. Yeah, for piano. Okay, in this case you can see the downbeats, it's a bit faint here, but believe me, you have again the same kind of velocity peaks. Just let me skip a little bit now. We have published some of this. So, yes, other studies that we do now is on ornaments, because ornaments have to be played very fast, like that. You cannot really deliberate each tone in an ornament. And we do that on violin, piano, cello, and percussion. And yeah. This is a fiddle player, Swedish Norwegian folk music, so it's very nice with the pitches. And if you study the motion data here, you can see it's practically identical. There's one deviation here, you can hear it. Okay, in other words, this is so practiced that it's just a snap and out it comes. Perfect, reproduced almost each time. Lastly, a drum fill. That's what I started with. Okay, here we see how the whole body needs to rotate. And in detail, again, this is published. If you like, you can have a look at it. But you see up here that you have the anticipatory motion all the time of the different components. Okay, so for further research, I'll stop there. I think we have arrived at some tentative insights, which may be a bit unusual, but I don't think they are far-fetched. Co-articulation in sound-producing body motion, I think, is documentable. And in the resultant musical sound, likewise, I think it's detectable that you have this smearing. Intermittent effort and intermittent control is something that we are working on. Velocity peaks at impact points is something that can be detected. And also the modeling and similarity is quite challenging, but hopefully we'll get there. So the major challenges here are really about getting good data from the electromyographic measurements, which is very tricky for us who are not trained in this. Fortunately, we have in our group now one biomechanics expert, which is very good, and he knows the difference between biceps and triceps and stuff like that, and know how to get good data out of seemingly hopelessly messy data, orders of magnitude more messy than anything we have dealt with before, but we believe it's worth it. So back to musical imagery. Musical imagery is a skill. Mind wandering is a skill. It's not just a pastime, but it's something that can be cultivated. That's what I end up with after having been more or less engaged with musical imagery now for 2.5 or 3 decades almost. And I believe that motion imagery may be a privileged access into imagery in general and musical imagery in particular. Furthermore, motion imagery is in fact multimodal because it's about visual trajectories, it's about quasi-stationary body postures, it's about proprioceptive and haptic sensations, sense of effort, sense of emotion, it should be, an effect. And lastly, we have, and this may sound a bit bloated, but I would say a sense of unlimited freedom to move and gesticulate, touch and listen to the sounds of our internal music, and to improvise in musical imagery. So that's it. Thanks for your attention.
Yeah, thank you very much, Rolf Inge, for this very inspiring and thought-provoking talk, which covered so many topics. I think, yeah, we'll have many questions from the audience. I have a couple myself, but maybe if the audience wants to start, and we have microphones going around. Any questions? Thomas has one, yeah.
Thank you, Rolf Inge. Wonderful. I mean, you spanned almost every topic that has been studied during the last 30 years, so it's very difficult to have any kind of a coherent, simple question. But I decided to start with one quite practical question about the direction that you are going now, like the EMG and working out the mechanics of these theories in a way, like transferring the biomechanical theories into music production. What they seem to be doing in biomechanics, they always disrupt the system. They weight down, they insert weights, or use chemicals to kind of disrupt the system in order to see what really contributes. Are you planning to follow that route as well in music production?
No, we are very aware of our limitations, so we try to really limit this to what we number one, can do, and number two, see as the most significant. But I am aware of that, and I think that goes also for a whole lot of other things, motion capture as well, that people may have different objectives for going into it. The reason why we chose EMG was initially the simple fact that we were curious. There was so much talk about effort, and you know, from the wonderful work of both you and Petri, this so-called inverse modeling, where, for those of you who are not familiar with this, it means that you can take motion capture data, and there was this guy called Dempster in the 1950s who did some very gory stuff. He chopped off hands and so on, and weighted 5 kilos, 6 kilos for the head. So when you have kinematic data, you can go backwards, and you can try to figure out what's required to accelerate the head at so many G's. So that of course, and very nice papers done with that. What we were trying to do is now initially to look at how you switch between different sets of muscles. So we have a paper in preparation now where we try to show how experts tend to minimize motion from the guessing or hypothesis that an expert will reduce motion to a minimum in order to not get strain injuries as a musician, but also to make the music smooth. So we are actually not trying to get at the definition of smoothness. What does that mean? It's not obvious, but there have been some other work that we are trying to study carefully. But again, to your question, I think at times I came from what we call armchair science point of view, and at times I long back to that. That life is so short and there's so much to learn, and the trivialities of getting a lab up and running, hiring people who can actually help you, getting the funding, it's a very long way to go, you know, all about this. So I hope that answered your questions. Yeah.
Yeah, further questions. Jin.
Thank you. I'm also always impressed by your talk, and so as far as experience your talk, you have always further ideas that you put, because I remember your talk in Oxford, instant-based experience, and so it is very similar. But I'm thinking, although it is similar, it is different, because impulse-based is actually a little bit physical and psychoacoustic aspect. But instant is actually, I remember this idea of Husserl too, as instantaneous experience. It's more experience related. That's exactly my question, because you are also interested in how we experience auditory object and sound object and even music, and you also argued maybe some musicologists are not satisfied with your hypothesis because large-scale unity is supposed in musicology. And my question is, okay, I understand your point, as many arguments were provided, constraints and so on. But in some cultures, we also have tendency to anticipate in very long, large scale, time scale. And of course, we can say about constraints that is almost like chunk, and so another term you also introduced. But what about this kind of what you call supra-chunk level that is also very central to music perception? Is it actually reducible to impulse and chunk level, or can you also differentiate kind of auditory object and musical objects? Because I think also this kind of discussion is also in speech research. And furthermore, related to the topic of the workshop, as imagery, not in general, but musical imagery is related to musical experience. And as you also mentioned, it is also dynamic. And that means that can be also within, you also excellently showed, within chunk level there is dynamics. But what about this large scale dynamics? Can our musical imagery also last a long time and be dynamic, and what kind of theory can provide this? Because you mentioned this is a kind of it's a convolution from impulse, but okay, I agree with that it's phenomenon, but is this actually that all that captures our experience of music, especially?
Yeah, well, thank you. I definitely see the issues there, and I agree with you. The point is to make some distinction between different timescales. That said, I'm very fond of, for instance, the Hindemith quote. I think I had to skip it, but he says in his book about his compositions that if you don't have this flash image of an entire composition, you're not a good composer. So it means that the macro perspective for him was very important. So sure, it does exist. And what I am a bit skeptical about is that maybe we are confusing two things here. One thing is very long, enduring experiences. Let's say in other cultures where you typically can have shamanistic drumming going on for hours and hours and hours. And on the other hand, you have in our Western culture where you have these huge works, operatic works, symphonies and so on, where there's a difference between what has been architecturally planned by the composer and put in and presented as a kind of immutable structure. What would happen if you chopped it up and presented a new structure, alternative structure, where you had the same temporal duration? That's one of the issues that I think is a bit discomforting. It's like in the theater world where you can sometimes change the length of plays. You can edit away a little bit of this and a little bit of that, and you can still tell the story. In music, nowadays, it doesn't really happen as far as I know. So, but again, I think that these are basically unanswered questions. They need to be really studied, and how to study large-scale forms and how to study that in relation to musical training. Again, this simple study, in a sense, by Eitan and Grano, showed that new Mozart sonata was pleasing to even experts. So that's maybe a bit limited case, but definitely it's something that should be looked into, instead of just accepting that I was a bit irreverent to the Schenkerian Urlinja, saying that the first movement of Eroica is like this. It shouldn't be just based on scores. It should be based on actual listening.
I have a question on motion imagery and your definition of it. You touched on it a little bit on the last slide and clarified what other modalities are involved with this. One thing that would be interesting to hear is how do you differentiate between self and other motion imagery? Is there something, do you distinguish between imagery related to motion that we experience in our own bodies compared to motion imagery that we experience in other people or even in objects? Is there any distinction, or could you maybe also call it kinesthetic imagery? Is that a term that you would say is a synonym for motion imagery, or is there any distinction that can be drawn?
Well, I think you can draw a number of distinctions, definitely. So when it comes to motion, you have, of course, the kinematic components, which are, the way I've seen the definition, is just a visual. Has no energy, it just bounces up and down, has no effort. So that's why I would like to say that sense of motion, body motion, is multimodal a priori, because it is kinematic, it's effort related, proprioceptive, the way it's usually defined is that you have an inner sense, you can close your eyes and you know that your hand is up there, you don't need to see it. That's proprioception. And then you have haptics. And what more? That's why I always recommend this book by Alain Berthaud's Le Sens du Mouvement. I think it's called The Body Sense of Movement in English, because he demonstrates very clearly that sense of motion is quite composite. So if I understood the other part, to what extent when we observe others, like observing Glenn Gould, yes, to me it's fascinating to see, because it seems to me that, of course, he plays the notes of Webern Opus 27, but he does kind of animate, he projects his own interpretation, and this wonderful last tone where he simulates an attack and a decay of a piano tone with this motion. So that would be theatrical, and I wonder if I was a television producer and said, Mr. Gould, very well, but could you please restrain your motions? I think he wouldn't appreciate that, because it's so ingrained in his manners. And then you can speak of music facilitating gestures in his case. And I'm guilty of the same here. I used one of the slides that I skipped. Kita is one of McNeil's pupils in Chicago, talking about speech facilitating gestures. I do this, we all do it, variably so, to somehow trigger our minds to speak. So it's again, this multifunctionality is tricky, but that's no impediment to getting into trying to classify it. And I think again that recognizing that you have very many dialects, so to speak, of motion, it's an enrichment, but the basic observation that motion is there and strengthens our perceptions of the world, I think is true.
Yeah, thank you. Any further questions? If not, I've got another one. Could you maybe clarify, for me at least, one of Pierre Schaeffer's approaches, and if it's possible to reconcile this with embodied music cognition? I'm referring to the repeated listening, acousmatic listening. So the idea is that by repeated listening, you detach yourself from the source of the sound, which to me seems to be just the opposite of what embodied cognition is about. So how do you reconcile that?
Very, very good point. And this is absolutely true if you read Schaeffer carefully, that he says écoute réduite, reduced listening, meaning that you are supposed to throw away any everyday significance of that. But what he does in parallel is that he presents all these very basic categories. And that's why I believe that motor theory is a kind of super theory that bypasses that. And this is controversial, I know, but to say that in the beginning was movement. And that's actually the first sentence in the Berthaud's book, where he quotes Goethe's Faust, am Anfang war die Tat. And his point is that movement is so basic that it permeates all other stuff. So again, this is of course debatable, but I think that when you look at what Schaeffer says about the impulsive, iterative and sustained sounds, he uses the French word facture, which means fabric, and I correlate that immediately with the motion that it induces. But I'm very aware of the point that you make, very good point, and with some Schaefferians I have had some discussions, but I think it's okay. Yeah.
Okay, thank you. Any other questions? If that's not the case, then I think we're going to still continue the discussion, and you're all invited to join us for a reception next door, which has been ready for quite a while, I think. But first of all, let's thank Rolf Inge once again for a wonderful presentation. Thanks so much.